Whether it's a surprise breakdown, maybe a routine inspection that you just can't miss, or even just someone reporting a weird noise from the machine downstairs. Maintenance tasks can really feel like this constant stream of demands. How do you even begin to bring order to that?
Oh, absolutely. That stream, if you don't manage it, it quickly becomes a flood, right? Effective workflow management is really the key to staying afloat, making sure those tasks get captured, prioritized, assigned, and, completed efficiently.
Totally agree. And that's exactly what we're trying to unpack today. We're doing a deep dive specifically into how Atlas CMMS helps you manage that whole flow. And we're drawing all our insights directly from the source you shared, the Atlas CMMS user guide, focusing on pages 66 through 123.
Right. Our mission, really, is to walk you through the core components that are detailed right there in those pages. We'll explore the specific tools Atlas gives you to manage maintenance from the moment a need pops up right through to completion. Looking at everything from those unexpected issues to planned preventive work, and even how requests get submitted by, pretty much anyone in your organization.
So we'll look at how manual tasks get handled, how planned maintenance gets put on the calendar kind of automatically, how usage-based stuff is triggered, and how those crucial initial requests actually get into the system. And I think most importantly, how all these different pieces connect up to create a single manageable workflow.
Exactly. It's about understanding the system not just as like a database, but as a dynamic engine that drives your maintenance operations.
Okay, let's dive in then. So at the heart of managing pretty much any task in Atlas CMMS is the work order. And the most flexible type, the one you'd use for anything unexpected or kind of ad hoc, is the manual work order.
Right? That's right. Manual work orders are the ones users initiate. They aren't scheduled automatically. You create one when something specific needs doing now, or, it doesn't fit into a recurring plan. Think of that classic sudden equipment failure, like a conveyor belt going down, or maybe a motor burning out. That's your typical manual work order.
Right, the reactive things. But the guide also points out they're used for other stuff too, like unscheduled but necessary tasks. Maybe a one-off compliance audit needs doing, or an ad hoc upgrade project. It seems like it's your tool for documenting and tracking anything that needs a specific non-recurring task assigned.
Exactly. It's that flexibility. And once you have these tasks piling up in the system, how do you actually, see them all clearly? The user guide shows us a few different views for that.
Okay. The most common one seems to be the table view. Looks like it lays everything out like a spreadsheet, columns for ID, status, title, priority, asset location, dates, all that standard stuff.
Yep. That's great for just scanning lists and seeing the key data points quickly. But for scheduling, the calendar view is really invaluable. You can visualize the work orders over days or weeks, see who's doing what, and spot potential scheduling conflicts just at a glance. There's also a column view mentioned, which could be useful for tracking tasks moving through stages, maybe. But the guide really focuses more on the table and calendar views.
I can imagine if you've got a busy operation, that list in the table view could get long really fast.
Yeah.
The pages you shared definitely detailed the filtering options. They look pretty extensive.
Oh, they are. You can start simple, filter by status, like open, in progress, on hold, complete, or filter by priority.
But the real power seems to be in those more filters, doesn't it?
Absolutely. That's where you can really narrow things down. By the specific asset involved, the category of work, is it corrective, inspection, the team assigned, or the location? And what's super useful for managing assignments is filtering by people like who created the WO, who's the primary worker, any additional workers, or even specific contractors.
And of course, you can filter by dates too, when it was created, completed, or last updated. It feels like using these filters lets you just cut through all the noise and focus exactly on the tasks that are relevant to you right now.
Precisely. They're really essential tools for managing your workload and also for reporting later on.
So, okay, you need to create a manual work order because something needs attention. The guide walked us through the form. What are the absolute critical pieces of information you need to capture when you're creating one?
Well, when you're creating a manual work order, getting enough detail in there right at the start is pretty key to getting the job done efficiently. You start with a clear, concise title and then a more detailed description of the problem or the task itself. The ability to upload images is huge. I mean, a picture really is worth 1,000 words when you're trying to show what's broken or maybe the work that needs doing.
Oh, definitely. That clarifies things immediately, I bet.
For sure. Then you set a due date and an estimated duration, which obviously helps with planning and resource allocation. Assigning a priority low, medium, high tells the team how urgently this needs attention. You also categorize the work, is it corrective, an inspection, calibration, something else. This helps a lot with reporting and analysis down the line.
And then you have to assign who's actually going to do the work. The primary worker is the main person responsible, right? But you can add additional workers or assign it to a whole team, and even tag a contractor.
Exactly. You specified the location and the specific asset too. And the guide mentions a helpful little feature here. If you pick the location first, the system can filter the asset list to only show assets at that location, which makes finding the right one much quicker.
Little usability things like that make a difference.
They really do. You can also attach standardized checklists. We'll probably talk more about those upload supporting files, and even require a signature on completion, which is really useful for handovers or certain compliance checks.
So capturing all this detail makes a work order a proper, actionable instruction, not just some vague placeholder. Now, who actually has the keys to the kingdom here? Who gets to create and update these things in Atlas?
Right. Based on the user guide, creating work orders is typically handled by admin, limited admin, and technician roles. Changing the status and, moving it from open to in progress, for instance, that's usually down to technicians and limited technicians. Deleting a work order, which is obviously a more permanent action, that's restricted just to admin roles. Assignment and reassignment also need specific permissions set up.
And how does the system keep everyone, in the loop so people know what they need to do?
Notifications are absolutely crucial. Atlas uses web push, mobile push, and email notifications to alert users. So you get notified when a work order is assigned to you, when its status changes, or if there are other important updates. It really helps ensure assignments don't just fall through the cracks.
Okay, so I'm a technician. I get a notification pinging me about a work order assigned to me. What are the sort of standard steps I take within the system as I actually start working on it?
Well, a really common practice outlined in the guide is to first hit that timer when you actually start working on the task.
Tracking that wrench time people talk about.
Exactly. The timer measures the actual time spent actively performing the maintenance, and starting the timer automatically updates the work order status to in progress.
Gotcha. What are the main statuses I'll likely be using then?
The core statuses described are open, which means the task is created and ready to go. In progress, meaning you're actively working on it, the timer might be running. On hold, which means work is paused temporarily. Maybe you're waiting for a part to arrive or an approval or some other constraint. And finally, complete, meaning the task is finished. Using these statuses accurately is really vital for tracking progress and, later on, analyzing performance.
Makes sense. Now, while I'm working, I might need parts from our inventory. How do I record using those?
You can add parts directly to the work order record as you use them from inventory. The system tracks which parts are being consumed by this specific job. And a really key point here is that when you mark the work order as complete, the system automatically adjusts your inventory levels to reflect the parts that were used.
Wow, okay. That's a major benefit for keeping inventory counts accurate. What about other costs? Things beyond standard parts from the stockroom.
Yeah, that's where you use the additional costs feature. These are basically expenses that aren't coming directly from your standard parts inventory. Think about things like specialist materials you had to buy just for this job, maybe renting a specific piece of equipment, paying a subcontractor, travel expenses, or even permits needed for the work.
And why is it so important to track those other costs separately?
The guide really highlights this, and for good reason. First, it ensures you have realistic budgeting data for future planning. Second, it allows for accurate profitability analysis, especially on larger projects or client work. And third, it's absolutely essential for client billing if you're doing maintenance work for others. Untracked costs like these can just quietly eat away at budgets and profitability.
So how do you actually add them in the system? What information do you need?
It's pretty straightforward. You add a description of the cost, note who incurred it, which worker or contractor, select a category for the cost, the date it happened, and the amount. There's also an interesting toggle switch labeled Include in Total Cost.
Okay, what's the purpose of that toggle? Why wouldn't you include a cost?
Well, it gives you flexibility. It lets you specify if this particular cost should be included in the main total cost calculation that's displayed for this work order. This is useful if, say, you have internal tracking costs, like maybe travel time for your own technicians between sites that you want to record against the work order for internal analysis, but you don't necessarily want it rolled up into the primary asset maintenance cost figure. Or conversely, if you are billing a client, you'd make absolutely sure the costs you intend to pass on are toggled on to be included.
Okay, that flexibility is definitely helpful. The guide mentions travel, rentals, emergency supplies as common examples. Now, speaking of tasks within the work order, what about using checklists?
Right, checklists are a really powerful tool. They're great for standardizing procedures, making sure nothing gets missed, helping with compliance requirements, and generally reducing errors, especially for tasks that are complex or done routinely. Within the work order itself, you'd go to the tasks section to access and complete them.
And the guide shows they're not just simple, like yes/no tick boxes, are they?
No, not at all. They support different kinds of data collection. You can have subtask statuses like pending or completed for individual steps within the checklist. There are text fields for adding notes or observations, number fields for recording actual measurements like pressure readings or temperatures, inspection checks for simple pass-fail points, and attachment tasks, which let you upload photos or files directly as proof of completion for that step.
And it looks like your inputs save automatically as you go. That's always a relief.
Definitely. Saves you from losing work if you get interrupted. Another neat detail mentioned is that you can assign specific users or even assets to individual tasks within a checklist. So maybe step 3 of a big inspection needs to be done by technician B, or it specifically relates to the engine component asset if the overall work order is for the whole machine.
That adds a nice layer of granularity. Okay, we talked about the timer tracking the overall wrench time, but how do you track the specific hours that different people might have spent on a job?
Good question. That's done using the add labor function, which is actually distinct from the main timer. The timer is more about tracking the duration the work order was actively in progress. Adding labor lets you precisely record hours for specific individuals. This is crucial if, say, multiple people worked on the job, or perhaps if not everyone used the timer consistently for whatever reason.
And why is tracking that labor time in detail so important?
The user guide lists a few key reasons. First, accurate cost calculation for the job, knowing the true labor cost. Second, efficiency analysis, seeing who spent how long on what types of tasks. And third, it provides essential data for billing or payroll purposes. Common examples where you'd use this are recording overtime hours, maybe time spent by a supervisor who wasn't actively wrenching but was involved, or even travel time associated with the job.
Okay, so you record who it's assigned to, their specific hourly rate, when they started work, the duration, and maybe a category for the type of labor.
Yes, and similar to the additional costs, there's that include this time in the total time toggle. This lets you decide if this specific labor entry should contribute to the overall duration tracked by the timer, or if it's purely for cost calculation or payroll tracking outside of that main timer. Again, it offers flexibility depending on exactly what you need to report on.
Interesting. The guide also describes linking work orders together. What's the point of that feature?
Linking work orders is basically a way to visualize and manage relationships between tasks that are technically separate work orders but are connected in some way. It helps show how different pieces of work relate to each other contextually.
What kinds of links are there? How can they be related?
The guide details 3 main types. Duplicated by, meaning this work order is essentially a copy of another one. Related to, which means the tasks are connected perhaps geographically, like inspecting multiple pumps that are all on the same pipeline, or maybe contextually related somehow. And split to, which is used when a large, complex work order has been intentionally broken down into several smaller, more manageable work orders. It really helps create a sort of network of related tasks, which is great for better oversight on complex jobs or projects.
Yeah, I could see that being useful for complicated issues or bigger projects. So once everything's done, the work is performed, the timer stopped, checklists are completed, parts, labor, costs are all added. What are the final steps for closing out a manual work order?
The main step is you mark the work order as complete. The system also allows you to print work orders, maybe for field use or for physical record keeping, and also to archive them, which moves them out of your active list but keeps them accessible in the system for historical data and reporting.
Okay. What if things change? What if the person originally assigned to a work order can't do it, or someone else needs to take over? How do you reassign it?
Reassigning involves editing the work order details. You can change the primary worker, add or remove additional workers, or change the assigned team. It's a fairly simple edit process right within the WO details screen. But the guide does touch on the management side of this. It's important to have clear communication about why the change is happening. Good documentation noting the reason for the reassignment is also key. And sometimes patterns in reassignments might even point towards training or development needs if they highlight skill gaps or maybe workload imbalances among team members.
Okay. That covers a lot on manual work orders, really the foundation for all the reactive ad hoc tasks. But Atlas CMMS also helps significantly with proactive maintenance, doesn't it? The planned stuff.
Oh, absolutely. That brings us neatly to preventive maintenance, or PM. The guide defines this clearly as scheduling tasks at fixed, regular intervals based on a specific frequency with the goal of preventing those unexpected breakdowns, reducing failures, and ultimately extending the life of your assets. It's all about the scheduled inspections, services, lubrications, etc., in contrast to the reactive manual WOs we just discussed.
Yeah, the routine checks, oil changes, the tasks you do before something breaks, hopefully.
Precisely. And the guide also briefly mentions condition-based maintenance, which is triggered by meters as another type of proactive maintenance. We'll definitely get to that next.
So how do you manage these scheduled PMs within Atlas? Is there a separate section?
Yes, there's a dedicated PM module. When you look at the list view there, you get an overview. You see the trigger name, which is basically what this PM schedule is called, its frequency, how often it runs, something called the due date delay, the next work order due date, who it's assigned to, location, category, and the asset involved. Now, what's absolutely critical to understand here is that each time a PM is due according to its schedule, the system automatically creates an associated work order.
Ah, okay. So setting up the PM schedule isn't just like setting a reminder in your calendar. It's actually configuring the automated generation of a standard work order every time it's due.
Exactly right. When you set up a PM, you're defining all the details for the work order that the system will create automatically down the line. You give that auto-generated WO a title, usually aligned with the PM trigger name, a description of the work needed, and a priority level. You also set the due date delay. Now this is the number of days after the system actually creates the WO that it becomes officially due.
Okay, so, for example, if a PM is due every 30 days, the system might be set to create the WOO on, say, day 25, and you could set a due date delay of 5 days, which means it would show as due on day 30, gives you a little lead time.
Correct. It allows you to give the assigned technician a heads up and some buffer time before the actual hard deadline hits. You also set the expected start date, which is the planned time for the work to begin, and the estimated duration for the task. This interplay between the PM frequency, the expected start date, and the due date delay ensures the work orders are generated with appropriate timing for your workflow.
Makes sense. Who typically has permission to set up and manage these automatic schedules? Is it everyone?
Usually not. Creating PM schedules is typically reserved for admin and limited admin roles. Rescheduling them or deleting them also generally requires those higher level permissions. Technicians don't usually create the PM schedules themselves, but they absolutely manage the associated work orders that get generated just like any other WO. They change the status, add parts, labor, complete checklists, etc. And importantly, they receive notifications when a PM work order is assigned specifically to them.
Got it. Where does the information on how often to actually perform a specific PM come from? That frequency setting.
Yeah, the guide briefly lists several common sources for that information. It could come from manufacturer recommendations for the equipment itself. It might be based on analysis of your own historical data failure rates, previous maintenance cycles. You might use benchmarking against industry standards for similar assets. Sometimes there are specific regulatory requirements you have to meet. It could be influenced by operational usage, how heavily the asset is actually used, or increasingly, insights might come from predictive maintenance technologies if you're using sensors and analytics. These external factors essentially inform how you configure that PM schedule frequency within Atlas.
Okay, that makes a lot of sense. So PMs handle the time-based proactive work. What about the other type you mentioned, condition-based maintenance? That uses meters, you said.
Yes, exactly. Meters are really central to condition-based maintenance in Atlas. The guide defines them pretty simply as counters or gauges within the system that track numeric values over time. Think about things like hours of operation on a particular machine, or the number of pieces produced, miles driven by a vehicle, maybe fuel consumption.
And they serve two main purposes, you said.
That's right. One purpose is just straightforward historical logging, keeping track of asset utilization or readings over time. Useful data in itself. But the second purpose, which is crucial for workflow automation, is using them to automatically trigger preventive maintenance work orders based on predefined thresholds you set.
So instead of automatically creating a work order every, say, 500 hours on the calendar, regardless of how much it was used, it triggers the work order when the meter reading actually hits 500 hours.
Precisely. That's the core idea. You find meters in their own dedicated section in the system. The list view there typically shows the asset the meter is linked to, its category, the reading frequency, that's if it's a meter that requires someone to periodically enter readings, who's assigned to take those readings, and importantly, any work order triggers that are linked to that specific meter.
Okay, so how do you set one of these meters up?
You create a new meter by giving it a unique name, selecting the unit of measurement. Is it hours, pieces, miles, degrees, etc., specifying its location and the particular asset it's monitoring, and then assigning the workers who are responsible for entering the readings for that meter.
And then to make it actually trigger a work order automatically, you need to add a trigger to it.
Correct. Once the meter is created, you navigate into its details page, and there's usually a button or option like bold plus trigger. This is where you configure the specific condition that will automatically generate a work order when met.
And what sort of condition do you set for that trigger?
You give the trigger itself a name, so you know what it's for. Then you define the condition based on the meter reading. Typically, it's something like one meter reading is greater than or lower than a specific value you enter. Then, just like when setting up a time-based PM, you configure all the details for the work order that you want to be automatically generated when that condition is met. You fill out those familiar fields like title, description, priority, who it should be assigned to, maybe standard tasks, etc.
And you can link multiple different triggers to a single meter, maybe for different kinds of maintenance at different levels.
Yes, exactly. You could have several triggers on one meter, perhaps a minor inspection trigger at 500 hours, and a major overhaul trigger at 5,000 hours, for example. The system then constantly monitors the meter readings that are entered, and as soon as one of your predefined conditions is met, boom, it automatically creates the corresponding work order you configured. That's really the power of condition-based automation right there.
Very cool. Who typically manages these meters and enters the readings? Is it the same people who manage PMs?
Permissions for creating, editing, and deleting the meters themselves are usually for admin roles. However, the task of actually entering the meter readings is often given to the assigned worker for that meter, or maybe limited technician or technician roles, basically, the people who are physically interacting with the asset regularly. Now, editing the status of the work orders that get triggered by the meter, that's typically done by technicians and limited technicians, just like any other WO. And of course, notifications are sent out for meter creation, for reading updates, and critically, when a work order is automatically generated by a trigger, the right people get alerted.
How do the users know when they're supposed to record a meter reading, especially for those with a set frequency?
Well, often when a meter is first created and a worker is assigned, they'll get a notification prompting them for that initial reading. For subsequent readings, for meters that are set up with a specific reading frequency, like read every week or read every 100 hours, the system prompts the user based on that frequency after the last reading was recorded. So you can take readings directly from push notifications, or you might see meters that are past due for a reading highlighted, maybe in red, on the main meters list. So what this means is if a meter needs a reading every 30 days, the system will prompt the assigned worker 30 days after they entered the last reading, keeping that cadence going based on actual data entry, not just the calendar. And yes, you can also go in and edit meter details later, like the name, unit, reading frequency, category, location, asset linkage, assigned tech, and even add or modify the work order triggers associated with it.
Okay, so we've got manual WOs for reactive tasks, PMs generating WOs based on time schedules, and meters generating WOs based on usage or condition data. But how does a maintenance need get into the system in the very first place, especially if the person spotting the problem isn't actually a maintenance professional, like someone in accounts notices a leak?
Ah, yes. That's the absolutely critical role of work requests. The guide defines work requests very clearly as the input to the whole maintenance process. They are the needs or issues reported by essentially any user who has access to the system. They're basically the front door for identifying maintenance needs.
And work orders, then, are the actionable outputs that might result from those requests, or from the PMs and meters we talked about.
Exactly. It's a crucial distinction. Not every single request submitted will necessarily become a work order. Maybe it's a duplicate of something already logged. Maybe it needs more clarification before action can be taken. Or perhaps it's something that gets handled differently outside of a formal WRO. The key thing here, which the guide really emphasizes, is accessibility. A wide range of people, often with just a simple requester role, can submit a request. It's designed so that anyone can report an issue they see, not just the dedicated maintenance staff.
Right, like an office administrator seeing a leaking pipe in the break room, or maybe a machine operator on the factory floor noticing an odd vibration starting up.
Precisely those kinds of scenarios. Users access requests through the requests menu item, and there's usually a little number next to the menu item indicating how many open requests are currently waiting for attention. When you go in, the list view shows key info, like the request title, description, priority assigned by the requester, its current status, and the date it was created.
Can you filter or search through those requests if the list gets long?
Yes, absolutely. You can filter them by their status, typically pending, meaning it's new and awaiting review, approved, meaning a work order was created from it, or rejected. And there's also a search bar to help you find specific requests if you know keywords from the title or description.
How simple is it for someone, say, that office administrator, to actually create a request?
It's designed to be pretty straightforward, using an add request form. They fill out fields that are actually quite similar to a work order. A title for the issue, a description. They can easily upload images or files, and the guide specifically points out you can use your phone's camera right from the mobile app, which is super handy. They can assign a priority level, maybe suggest a due date, expected start date, and estimated duration if they have some idea. They also select a category for the request using the same standard list of categories as work orders, which helps with consistency, the location where the issue is, and the specific asset involved if they know it. They can even suggest a primary worker or team who might handle it, although the final assignment decision will usually be made by the maintenance management team during the review process. The key is for the requester to provide as much clear information as possible, especially since they might not be technical experts themselves.
Okay, so a request gets submitted, and it starts off with that pending status. What happens next? Who looks at it?
Right. Those pending requests go into a queue, essentially, to be reviewed by someone with the appropriate permissions, usually an admin or a limited admin role. They then have two primary actions they can take based on the request.
Okay, action number 1, approving it and assigning a work order.
Exactly. If the request is valid, seems necessary, and requires maintenance action, the reviewer approves it. When they click Approve, the system then automatically opens a brand new work order form, and crucially, it pre-populates that form with all the details that were entered in the original request: the title, description, asset, location, category, etc.
Oh, nice. So it seamlessly converts the information from the request into the beginning of a work order without needing to copy and paste or retype everything.
Exactly. It saves time and reduces errors. The admin or limited admin then adds any additional details required to make it a complete work order, like confirming the specific assignee, adding detailed task steps or checklists, finalizing start due dates, and so on. Once that new work order is saved, the status of the original work request automatically changes to approved.
Okay, and what's action number 2? Rejecting a work request.
Right. If the request turns out to be a duplicate of an existing issue, maybe it's unclear and needs more information, perhaps it's deemed not necessary, or maybe it's something that falls outside the maintenance team's scope entirely, then it can be rejected. The reviewer clicks the reject button, and they usually have the option to add some feedback explaining why it was rejected. This provides important transparency back to the person who submitted the request.
Makes sense. What about the permissions around requests? Who can do what?
The guide lays this out pretty clearly. The basic requester role can, obviously, create requests. Various roles like requester, limited admin, and even viewers can typically view the details of submitted requests. Now, a key point is about editing. The original requester can only edit their own request while it's still in the pending status. Once it's been approved or rejected, they generally can no longer edit it, but they can still view its final status and any feedback provided. The power to actually update, approve, assign, which creates the WO, and reject requests lies with the limited admin and admin roles. And once a request is approved and becomes a linked work order, other relevant roles like technicians can then view the status updates on that related WO as it progresses.
And notifications keep the original requester in the loop throughout this.
Yes, that's a really important part of closing the loop. Notifications are typically sent for request creation, and importantly, for request updates specifically, whether it's been approved and maybe assigned, or if it's been rejected. This feedback loop ensures that the person who took the time to report an issue actually knows what happened with it, which helps foster trust and encourages people to use the system.
Right, so the requester can always go back into the system and check the status of the related work order if their request was approved, or they can see the feedback explaining why if it happened to be rejected.
Precisely. It ensures they're not just shouting into the void, it closes that initial communication loop.
Okay, this is great. We've walked through manual WOs as the backbone for reactive tasks. We've seen how PMs automate work orders based on time schedules, how meters automate them based on usage or condition, and now how work requests provide that accessible front door for anyone to report an issue. How does Atlas CMMS manage to pull all these different pieces together into one sort of cohesive workflow?
Well, the real power, as highlighted in these pages, lies in their tight integration. You've got work requests acting as that flexible input channel, which can be formalized into actionable manual work orders by the maintenance team. Meanwhile, your proactive strategies, those PM schedules based on time and the meter triggers based on condition, they automatically generate work orders directly into the system without manual intervention.
And the critical point seems to be that all these different types of work orders, whether they started manually, were generated by a PM schedule or triggered by a meter reading. They're all managed through the exact same system, using the same tools and processes.
That's absolutely the core insight you get from digging into pages 66 to 123. They all live under one roof, so to speak. They all use the same features for tracking their status, for assigning staff, primary worker teams, etc., for logging time spent, for consuming parts from inventory, for adding those other additional costs, and for completing standardized checklists.
So that centralization really brings everything together. What are the sort of big picture benefits you gain from using Atlas in this integrated way, as the guide seems to outline?
Yeah, the benefits really start to compound when you see it working together. You get a much more streamlined process overall, definitely reducing manual effort and the potential for errors, especially through that automation coming from PMs and meters. There's significantly better tracking and accountability because every single task has a clear owner, a defined status, and recorded time and costs associated with it.
And using standardized procedures through those checklists means tasks get done more consistently and correctly, hopefully regardless of which technician happens to do them that day.
Exactly. Plus, you achieve much more comprehensive cost tracking by systematically pulling in not just parts, but also labor hours and rates and all those miscellaneous additional costs we talked about. Clear communication flows much better through the built-in notification system, keeping everyone informed. And perhaps most importantly, over time, you build this incredibly valuable wealth of data for analysis, real data on task completion times, true maintenance costs per asset or task type, patterns and requests, detailed asset history, and so much more.
So it really moves beyond just ticking boxes to say, yep, maintenance happened. It's about gaining deep visibility and genuine control over the entire maintenance function.
It really is. It's about making that shift from constantly reacting to chaos towards a more proactive, planned, and data-driven approach to managing maintenance.
Okay, so we've really taken a deep dive here into the core of workflow management within Atlas CMMS, all based on these specific pages from the user guide. We've covered how manual tasks are handled with all that detailed tracking for time, parts, costs, and checklists. We looked at how preventive maintenance schedules and meter readings can automate work order creation. And we saw how the work request system provides that simple, accessible entry point for absolutely everyone.
And understanding how these integrated workflows function together, as they're detailed quite thoroughly in pages 66 through 123, is truly fundamental, I think. It's like having the map that helps you navigate from just doing maintenance tasks reactively towards strategically managing the entire maintenance operation effectively. It can really turn that feeling of, juggling flaming chainsaws into something that feels more like a well-oiled machine.
Yeah, absolutely. And whether you're the person reporting an issue through a request, the technician on the ground actually performing the repair or an inspection, or maybe the manager overseeing the whole operation, seeing how these different tools and processes, the WOs, PMs, meters, requests, all connect within Atlas, it really gives you that clear picture of how work flows through the system and hopefully how you can make it more efficient and effective.
So maybe here's a final thought to consider. By capturing all these different maintenance streams, the reactive stuff, the time-based PMs, the condition-based triggers, and those user-initiated requests, and flowing them all through one structured, integrated system like Atlas, you're not just getting tasks done more efficiently, you're actually building this incredibly rich data set about your assets, your processes, and your operations over time. What sort of hidden patterns about equipment reliability, or maybe the true lifetime cost of certain assets, or perhaps resource allocation inefficiencies? What might emerge when you start connecting all that workflow data together and really analyzing it?